All right, counting permutations, whoops, and combinations. Sorry, I just threw my pen, but we're good. So, fun fact, crows recognize human faces and hold grudges against ones they don't like. Dude, you guys need to look up crows. Crows and ravens are the smartest birds. I'm slightly obsessed with them currently, but anyway, anywho. Okay, so counting. So there's lots of different ways to count things. Okay, so when there are multiple events, to find the total number of ways all events can occur, you multiply the number of possible outcomes at each stage. So what that means is, let's go through an example. So there are 3 roads to Crawford, from Crawford to Milford, and then there's 4 roads from Crawford to Millsville, and then 4 roads from Millsville to Lakeport. And we want to know how many different ways are there to get from Crawford to Lakeport. Okay, so we have the city Crawford, and then we have Millsville in the middle, and then we have Lakeport. So there are 3 routes that we can get to Millsville. So we could take any of those 3 routes. And then from Millsville, we have 4 routes to get to Lakeport, which means that since there's 3 routes to get to Millsville and 4 routes to get to Lakeport, there would be 12 routes total that we could take, which, makes sense because, this would be a route. We could take this one, and then we could go here, 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 here. So there's 4 of them. Or we could take this route and then do there, 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 there. So there's another 4. Or we could take this route and then go here, 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 and here. Okay? Let's look at another example. So there's 12 routes from Crawford to Lakeport. So in a restaurant, there are 5 choices of soup and 4 choices of salad. And if a person orders soup and salad, how many possible choices are there? Well, if there's 5 choices of soup, we could choose any of the soups, and we could pair any of those soups with one of the salads. So we have 5 times 4, which is 20. So there are 20 possible choices for a soup and salad. Okay? So factorial. A factorial, I don't know if you've ever seen an exclamation point in math, but an exclamation point, that is an actual thing in math. It's not like mathematicians got really excited and they're like, 4! That's what golfers do. But anyways, so 4 exclamation point means 4 factorial. And really what you do is you take whatever number it is and then you just go down by 1 each time and you multiply them. So 4 factorial would be 4 times 3 times 2 times 1, which is 24. Okay, so when you want to find a number of different arrangements of a certain number of items, you can use a factorial. And it's just written like n exclamation point, which reads as n factorial. And there's a button in the calculator for this. I'll show you guys when we're in class. But, for example, so if we want to find 5 factorial, that's going to be 5 times 4 times 3 times 2 times 1, which ends up being 120. Okay? So what about this one? Erwin has 6 books to arrange on a shelf, and how many different ways can he arrange them? So Erwin, if he has these 6 slots, I guess, 3, 4, 5, 6, that we can arrange them. Well, there's 6 choices for which book we want to put in that first spot. We could choose out of the 6. But then we've put 1 there, so then we have 5 choices here. And then we've put 2 books there, so now we have 4 choices. And then we have 3 choices, and then we have 2 choices, and then we have 1. So we just have to find 6 factorial, which is 720. So there's 720 different ways he can arrange the books on his shelf. Okay, now we're going to switch gears a little bit and permutations and combinations. So first, what is the difference between, we've heard this word, I know you've heard the word combination. You have combinations to your locker, you have a combination to get into your phone, there's a pin, right? Well, those should probably be called permutations, first of all. But, so the difference is, in English, we use the word combination pretty loosely, which was what I was just talking about. So here's some examples. My fruit salad is a combination of apples, grapes, and bananas. We don't care what order they are in. They could be bananas, grapes, and apples, or grapes, apples, and bananas. It's the same thing. It's the same fruit salad, right? But think about like a combination. Like I have a combination. We put locks on the gates to my backyard. And so I have combinations to those. So if the combination to the safe is 472, well, I do care about that order, because if you put in 724, that won't work, and neither will 247. Same with like your phone. So if you probably have a code to get into your phone, or now these are so smart, they just like look at you and unlock, but it's creepy. Anyways, but you can just put in your PIN and say your PIN was like 1234. Well, if you put 4321, that's not going to work, right? So in math, we use more precise language. So when order doesn't matter, that's a combination. And when order does matter, that's a permutation. Okay, so this should be called a permutation, not a combination. Okay, so one way to remember this is a permutation is an ordered combination. And something to kind of help, I guess, is think permutation and position. Like we care what position the numbers are in for the permutation, and the combination we just don't care. It could be anything. Okay. So permutations, there are two types of permutations. There's one where repetition is allowed, such as lock above. So like 333 would be allowed. Or like you could have a code of 1224 or something. And there's some where no repetition is allowed. So like if you're talking about people, for example, if the first three people in a running race, well, I'm not going to be the first and the second person. Like you can't get first and second place when it's an individual thing. Okay, so permutations with repetition are the easiest to calculate. When a thing has n different types and we have n choices each time. So for example, if we're choosing 3 of those things, the permutations are n times n times n. So it'd just be like n to the rth power. And I'll go through some examples here. So let's look at this down here. In the lock above, there are 10 numbers to choose from, so 0 through 9. And we choose 3 of them. Well, so 3 of them, well, I could choose any number for this one. I could choose any number for this one, and I could choose any number for that one. So I'd end up getting 1,000 different permutations that we could use there. Okay? So if you just think n to the r power, or you could write it out. Now, permutations with repetition, and these are a lot of the ones that we will see when we're doing this, but we have to reduce the number of choices available each time. So first, we want, what order could 16 pool balls be in? Well, if we had 16 like slots, I guess, because we could choose the first pool ball and we have 16 options for that pool ball. And then we have 15 for the next, and then 14 for the next, then 13 for the next, and blah, 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 and so on. Clear down to 1, and there are this many choices for how to order those pool balls, which is crazy because there's only 16 of them. Like, it kind of blows your mind, right? But maybe we don't want to choose them all. We want to choose just 3 of them. So how many ways can we order 3 of the 16 pool balls? Well, for the first, we have 16 options. For the second pool ball, we have 15 options. And for the third pool ball, we have 14 options. So there are 3,360 options for those pool balls. Okay? So in other words, there are 3,360 different ways to order 3 pool balls out of the 16. Without repetition, our choices get reduced each time. Okay, and there is a formula for this, and I would write this formula down. So this is the permutation formula, and it's n factorial over n minus r factorial, where n is the number of things we choose from, so that's like our total number, and r is the ones we are taking out. Okay, so like in our previous example, n would be 16, and r would have been 3. Okay. So like we could have done it this way, 16 factorial over 16 minus 3 factorial. Well, that's 16 factorial over 13 factorial, which we still get 336, which honestly is a little bit easier to just calculate this way. Okay? We're going to do another example later. So here's just some notation for this. So there's different ways. Permutation can be written like this. So it'd be like permutation, the number with the R value. Or it could be written like this with a superscript and a subscript. Or they're both subscripts. Okay, you'll see it all different ways. Now let's talk about combinations. There's ones where repetition is allowed, and there's ones where there's no repetition allowed. We are not going to do the ones with repetition in this class, okay? So let's look at the ones without repetition. This is how lotteries work. So numbers are drawn one at a time, and if you have the lucky number, no matter what, you win. So I don't know if you've ever seen a lottery ticket, but basically you have this, and then there will be like 13, 21, 7, 4, 93 or something. And when they draw the numbers, if you got like a 21, also I think you need like a certain number of these. I honestly don't know, but if you say you'd probably win like, I don't know, $10 for having that one number. Okay. So going back to our pool example, let's say we want to know which 3 pool balls are chosen, not in order. We already know that 3 of them gave us the 336. But now let's say that we don't care about the order that they're chosen. We just want 3 pool balls to be chosen, but we don't care about the order. Okay, so for example, let us use balls 1, 2, and 3 are chosen. Well, if order doesn't matter, so say order does matter, well, we have 6 different possibilities here when order does matter. But with combinations, order doesn't matter, so we really only have 1 possibility there. Okay, so that's going to change this a little bit. So there's a pretty easy, let's go back to this. So there's an easy way to work this out. So 1, 2, 3 could be placed in order, and we've already talked about this, but that would be 3 times 2 times 1. So 4 could be 4 times 3 times 2 times 1. Okay. So to adjust our permutations to reduce it by the number of objects that could be order, that we aren't like interested in that order anymore, it just changes our formula here from the permutations to combinations where we have an R on the outside. Okay, so we just have to reduce it by that number of the ones that we don't care about repeating. Okay? Let's go through some examples. It's important to know when to use combinations versus permutations, and it's helpful to look for keywords. So there's combinations, which look for like committee, group, team, toppings, or permutations where you look for like arrangement, order, or sequence. Okay, let's do a couple examples. So this first example, we want to know how many different 3-person committees can be chosen from a group of 10 names. Well, committees, that tells me that this is going to be a combination because I don't care about the order. They're just a group of people in a committee. So then I'm going to use this C formula up here, this one. So that's going to be C 10, 3. So that's going to be 10 factorial over 3 factorial times 10 minus 3 factorial. So 10 minus 3, well, that's just 7 factorial. So this is going to be 10 factorial, which is 10 times 9 times 8, blah, 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 over 3 times 7 factorial. So I did the 3 factorial right here and the 7 factorial right here. Okay, and notice here, we have some repeating things on top and bottom. So I can just cancel those out. And then I have 10 times 9 times 8 over 3 times 2 times 1, which is 720 over 6, which is 120. There's also a way to do this in the calculator. I'm going to show you guys on whenever I see you, okay? Let's do this one. How many different ways can a president, vice president, and a treasurer be chosen from 10 names? So this one is a permutation because we care about order. There's a president, there's a vice president, and there's a treasurer, okay? If you get chosen to be president and we didn't care about order, then that means that you're also the treasurer and it gets all messy. So this is a permutation. So then this would be the permutation of 10 and 3. that's 10 factorial over 10 minus 3 factorial, which is 10 factorial over 7. And then we could write it all out. Those cancel, and that's 10 times 9 times 8, which is 720. So there's 720 different ways that someone can be president, vice president, and treasurer. Okay, I think this is the last one. So a DJ has 14 songs to play in the next hour. And how many different ways can he choose to play the first 3 if he's not concerned with the order in which they play? So if we're not concerned with the order, that means that this is a combination. So that's going to be 14 over 13 times 14 minus 3. 14 factorial over 3 factorial, 14 minus 3 factorial. So 14 factorial over 3 factorial, 11 factorial. And that goes down to be 364. Okay, what if we care about the order? Well, that would be a permutation. So that's 14 over 14 minus 3. So 14 factorial over 11, which is 14 times 13 times 12, which is 2,184. Okay. See ya. Sorry, this was kind of long. Hopefully you watched the whole thing. Bye, guys.